All right, the last technique is kind of a grab bag technique where we have a couple of special types of parameterizations that we do on the regular that we would like to have formulas for. And the main ones are parameterizations of like planes, parallelograms, and triangles inside three-dimensional space. And they're very, very handy, very quick parameterizations that are much easier than the typical things we would get by solving for one variable in terms of another. So to parameterize things, we usually need a point and we need two direction vectors. Let's talk about parameterizing a parallelogram. If we've got a point P and we've got two direction vectors, one that goes from that point to one corner and one that goes from that point to another corner, both of them adjacent, then here's a formula for the parameterization of the parallelogram that has all four corners. Phi of st is equal to our start point plus s times our first vector plus t times our second vector. And we always, when we're using this particular parameterization, go between 0 is less than or equal to s is less than or equal to 1, and 0 is less than or equal to t is less than or equal to 1. If you like what this is doing, is this is drawing like a nice flat coordinate grid on our parallelogram. And I apologize for having my knuckles in the picture while I draw on my screen. This draws a nice coordinate grid on our parallelogram where the coordinate lines are perfectly parallel to the sides of the parallelogram. It's much nicer than what we would get if we solved for one variable in terms of the others. When we increase s, we're kind of going in the direction parallel to our first vector. And when we increase t, we're going in the direction parallel to the second vector. When t is 0 or 1, we hit the two of these sides, and when s is 0 or 1, we hit the other two sides. Parameterization of a triangle is very similar. For a triangle, we typically have three corners. We have our point, and another that's gotten by traveling along a vector v, and another that's gotten by traveling along a vector w. It has the same parameterization formula, except now instead of the square, where s is between 0 and 1 and t is between 0 and 1, we go over the triangular region where they both add to be less than or equal to 1. So it's like, basically it's like we take the parallelogram, which would be the whole region, and we ignore part of it. We only use the region that goes from between these appropriate corners. So as an example, here's a triangle. It's got three corners, 1, 1, 1, 2, 3, 5, and 1, 2, 0. One way to parameterize it is to say, let's choose this point, 1, 1, 1. Here's two direction vectors, which we get by subtracting to get from the point 1, 1, 1 to the others. They give us the vectors 1, 2, 4, and 0, 1, minus 1. And then our parameterization is phi of st is our start point, plus s times our first vector, plus t times our second vector. And if we simplify that, we get this formula, 1 plus s, 1 plus s plus t, 1 plus 2s plus t, and 1 plus 4s minus t. There's a lot of choices involved here. I could choose three different start points, and I could choose two different orders for the other vectors, which I choose as first and which I choose as second. That gives me 6 formulas for the parameterization. All of those are perfectly valid. It just depends on which choices you make at the beginning. And here, I should note that I have to stick for my parameterization to s is less than or equal to 0, or greater than or equal to 0, t is greater than or equal to 0, and s plus t is less than or equal to 1. So that's our region where we parameterize this triangle. All right, Q.